Welcome everybody to episode 3 of the X plus Y factor. So today we have Dr. Mark MacDonald, who is the Director of Undergraduate Teaching in the department. So he also teaches one of the big courses in our second year, Linear Algebra. And so he's going to say a little bit about his teaching of that, but also the overall picture for the undergraduate teaching, what kind of plans we've been making for the teaching next year, and so on. So this episode might actually be of interest to current students as well as the applicants and perhaps sort of prospective applicants that would be viewing the first two. First of all, just to notice that just as last week, we're a little bit late getting a solution up to Bernd's problem from last week. So that will be posted on the website, and there'll be a link to that down in the description box below. That will be produced in due course. Mark, welcome onto the show, I suppose we should call it.
Thanks for having me.
Can you just say a bit about how long you've been in Lancaster, what your role is, and maybe a little bit about your research area?
Well. Sure, yeah, thanks. I'm Mark MacDonald. I've been in Lancaster since 2012. So my research area is broadly algebra, I suppose, and the pure math section. And my role, the main role in the department is the Director of Undergraduate Teaching. So and I'm also, as you say, lecturer for this big second year module. So do you want me to say a little bit more about that role, or?
We will come back to it a little bit later. Your research area?
Yeah, algebra. So like algebraic groups and their representations. I could say a little bit more.
So these are just like me. In fact, of the
quite close to you, really.
Yes, Mark and I are sort of very close in our research interests. So we've only had pure mathematicians on so far. The next episode we'll have a statistician, so giving a broader spread of members of the department. But sort of just like it's very difficult for mathematicians to explain their research area to members of the public, it can also be a bit difficult for mathematicians to talk to each other about their own research in any detail. But you and I have quite sort of close research interests, so we quite often chat about sort of different problems, don't we?
Yeah, sure.
Yeah. Okay, so we'll come back to the research a bit later on. So the Director of Undergraduate Teaching, which is the official role, I think you've been doing that for maybe 3 years? Or
that's right, yeah, 3 years. This is the third one now, coming to an end. So,
right.
Yeah, it's been so in the department, it's a leadership role. There's the undergraduate programs are, big things. They're continually undergoing change. And I think the main aspect of this role is sort of ushering in such change. One thing I like about the role is how there's a lot of different stakeholders. So there's the staff, there's the academic staff, there's the admin staff, there's these PhD students, university level, undergraduate students, and there's all these different people who have kind of competing desires, and it's kind of just charting a course forward is it's a challenge, but I sort of like this challenge, getting a consensus. So yeah, that's what I'd say. Another thing, so the recent events, I guess, has made it quite a critical time, and decisions in the university I'm learning much more about how they work, and roles like mine across the department, quite a lot of so I'm not saying this very well, but there's been a lot of communication that's had to come from us, and I think this has been one of the challenges, communicating with students and staff, but hopefully we've managed it in this time. So
okay, so yeah, I mean, what you're referring to there is kind of trying to get communications out to students, for example, who are wondering what on earth is happening with initially with their courses, and then with their exams and their assessment, and what's going to happen to their marks,
so normally, I would say in our department and departments in general, we have quite a bit of autonomy, really, to making decisions and taking programs forward. And this recent time, it's really that's been decisions have been made from higher up, and so it's been very difficult to sort of like, I can't say too much because I don't want to be overruled, and it's been a challenge. But hopefully, in the not too distant future, we'll have some autonomy back to go forward. Yeah.
Yeah. So I guess the result for this year, students have been informed by email. We talked about last week about first year students because Brent is the department director. So first year students have received kind of certain messages about the courses that we're running and then the progression to year two. But the students in years 2 and beyond, perhaps it's been a little bit more difficult to sort of decide exactly what's happening. And quite early on, we as staff were told that there won't be any exams, but of course that leaves a question: what is going to happen instead of exams? And I think that the Part 2 students should have been informed now of what by email as to what is going to happen to their marks. Is that right? With some.
Yeah, pretty much. I think the marks haven't quite been finalized yet, but the process has certainly been all laid out. Yeah, I mean, these are difficult decisions that were taken fairly high up in the university. There was some consulting and stuff, but it was a difficult problem. I mean, there was a lot of issues that had to be resolved. I mean, doing some sort of exams just was not possible in the current situation. Take-home exams, there's internet access problems, there's an inclusivity question, and so there's quite a few considerations that led to that decision. Ultimately, I think it was the right one.
Yeah, but of course, then the detail of how you calculate marks based on coursework is there's sort of some sort of adjustment that needs to be made to try and make that as fair as possible.
That's right. Yeah, so we're in that process right now. So
and the external examiners may have some input there.
Absolutely.
Yeah, so it's kind of, I think written communications can sometimes be really difficult because they sort of set in stone something which you have to be very, very careful about the wording. And then being careful about the wording, it can sort of look like you're not even saying anything at all, which is one of the reasons I thought that these kind of YouTube videos would be better, because when you're speaking, you can convey nuance in a better way, in a way that is less open to misinterpretation. So that's kind of one of the things that I thought was a benefit of this. So if there's any current students watching, they can perhaps see that, yeah, we've sort of, as a department, it's not something I'm involved in, but as a department, the decisions have kind of more or less been made, but there are still the correct processes that need to be gone through. Just as you would do any year, you would need to go through the processes where you have external examiners, you have checking that all of the marks are correct and all of those things. It needs to get agreement by all of the relevant sort of levels of the university. So would you say that that's kind of like, so thank you for your patience, but you know, we will be absolutely clear as to how your marks are calculated when the time comes, when they're communicated to you.
Yeah, absolutely. I mean, it's sort of, there's a lot of competing concern. You know, student anxiety is one of the key concerns, I think, from the university all the way down, that we're very conscious of, and we want to make sure that we're not unnecessarily causing anxiety of students. So, yeah.
Right, okay, so can I take us through, we talked about assessment for this year, which we had to adapt extremely quickly, and then it essentially was unavoidable to cancel the exams. Now, next year, and I said this on the last 2 episodes, next year I was led to believe that there probably wouldn't be any exams next year, but I think that the latest thing I've seen is slightly different to that. It says that exams probably will take place, but they might well take place remotely next summer. Is that correct, or?
This is a crystal ball territory. I think it's too early to tell, unfortunately. Right.
Okay.
Yeah, I think we haven't made a definitive decision on that one.
Okay, but we can't guarantee that exams will take place in the normal way next year, because we don't know what's going to happen in the summer term. They would have to be scheduled quite early. So
that's right. We haven't ruled it out, I think, is the key thing.
So it's not ruled out, but then another possibility might be having online exams with 48 hours, where people have 48 hours to return them, because the 48 hours is taking account of the fact that people might not have internet access and so on. So
yeah, I mean, it's a less than ideal situation, but it may be forced upon us. Yeah.
Yeah. Okay. So I mean, I hope people understand the kind of uncertainties that we're going through, that we're trying to adapt. I mean, that's what I keep saying. We're trying to adapt to the situation in real time. The pressure on us from an admissions point of view is that we are trying to communicate to current applicants what the planning is going to be for teaching to take place next year, starting in October, which they have a right to know, and the Office for Students has been very actively pushing for that. But we're also sort of trying to leave enough flexibility to do, what will be the best in the situation. So we might have some timetable classes. I think the likelihood is there will be some timetable classes, but maybe lectures might be sort of impossible if there are some restrictions on social contact on campus and so on. But as I sort of keep saying, whatever happens, we will make sure that the sort of teaching experience is as sort of rich and as there's as much possibility for interaction with staff members and other students and so on. And in fact, we were chatting about one or two ideas before we started this call, weren't we?
Yeah, absolutely. And I think that's going to be a focus for the rest of the summer, is trying to maximize the experience for students going forward, regardless of the circumstances. It does seem at this stage that there's going to be some sort of social distancing thing requirements. So that's one of the things we're trying to work into the planning, but it's hard to know with certainty.
We know as little as anybody else on that.
Right.
We have a magic line to the government that says, yes, this is going to happen on whatever date. So, I
mean, it seems clear that we won't have, lecture theaters packed full of students. That's probably not going to happen.
Yeah, there's been some talk over the past week of coming from Universities UK of this sort of social bubble idea, which is maybe having groups of students in groups of 8. Now, I know nothing about that. I don't know whether that would be practical at Lancaster University, and I guess there will be some communications from the university in due course about whether that might work. But we're focused on the teaching side of things. So if we're told that lectures won't be possible, then we've got to have some other plans for that. Now, over the last couple of weeks, we've had these sort of meetings of teaching staff in the department discussing the way forward, and they've been really interesting, right? I mean, lots of ideas being thrown around, but coming to a firm conclusion is obviously a lot harder.
That's right, but I think our teaching staff are definitely engaged in this and ready for the challenge, I think, going ahead. One of the, I think, ideas for me that's come out of these meetings is the desire to have small groups of students working together. I think this is something that's much easier to do if there's lots of face-to-face contact. And I think in a more online environment, that's something we're going to need to kind of orchestrate potentially. So I think that's something to consider going forward.
Yeah. So we talked about assessment last week, and so trying to design assessment which would better work in a system where people are being taught at least some of the time online. Mm-hmm. And thinking about sort of creative forms of assessment. This is sort of ongoing assessment because at Lancaster we have these sort of homeworks once a week or once a fortnight or something that students get feedback on, don't we?
Yeah, exactly. So, and that's a crucial part that's definitely going to stay. I mean, this is an important part of the learning experience, practicing questions, getting feedback on that, improving learning like that. So this is going to stay. Is the mechanics of it are, because of the situation, necessarily going to change, but I think we'll be able to still deliver that. We'll still have the team of PhD students who are, eager to help, and teaching staff who are up for it. So, yeah.
Yeah, it's quite interesting as well. I mean, we had one or two graduate teaching assistants, didn't we, who are speaking, at least in some cases, as recent former undergraduate students.
Yeah, sure.
So that they are currently doing a PhD, but they also said, well, when I was an undergraduate, this is what I felt. And it's interesting to get the sort of the student voice, almost the student voice on there. I'm not.
Yeah, for guys like us, it's a bit further back, isn't it? To remember when I was a student.
Yeah.
I still remember it a bit.
I mean, some students sometimes say there's too much assessment, but I think that overall the kind of, the regular feedback is highly valued. So that's something that we definitely want to keep, isn't it?
Yeah, absolutely.
But at the same time, we've also got the technological sort of conundrum. I've managed to get myself a sort of writing tablet, which I haven't learned how to use properly yet, but you're probably familiar with this already. Have you used this before?
A bit on tablets. I've also done a sort of home visualizer, use my iPad as a visualizer essentially. So it
Yeah.
captures my handwriting on a piece of paper, which has worked well. But there's several solutions we're exploring for next year. Yeah.
Well, did you do that for your revision lecture this?
I did,
Stuff?
yeah. Sort of in the absence of such a, I mean, I'm at home. My equipment was limited. We didn't have time to plan this, but I happen to have an iPad, and I set it up so that it recorded my handwriting, and that worked fine. So
Yeah, the best I could do was sort of write out sort of maths, take a photograph, then write out a bit more and take another photograph and have a sort of a PowerPoint, which is close-ish to the same experience, but I think it's better to have the tablet. So yeah, I mean that's the kind of thing we're also thinking about the sort of practical best practice which people can learn relatively quickly, because we don't really have time to do a sort of a 3-year course in digital learning or anything like that. So we've got to try and think about something which is sort of adaptable for the current lecturers, don't we? Yeah.
sure, yeah.
So some of them, like Johnny, who we had on the first episode, has already been thinking about this before. So it's good to have them around to really learn a lot from what their practice has been in the past and what's worked well and what hasn't worked well. And as I said last week, I've also got the advantage this coming year because I'm teaching a graduate course in the Michaelmas term, and then I'll be doing complex analysis after Christmas for the undergraduates. So I'll get to practice a bit the remote learning kind of capability. And another possibility, of course, we talked about is maybe converting that room into one where you can sort of you can film sort of pre-recorded lectures and so on. So I guess that the sort of uncertainties are still sort of kind of quite a bit of our thinking, but we're sort of moving on to what we're kind of fairly sure is going to be the picture, at least for the Michaelmas term. We know there's going to be probably going to be some online teaching, some remote teaching, pre-recorded lectures. We're hoping that we'll be able to have kind of workshops, which are in smaller groups, but we're thinking about alternatives if we're not able to do that, if there's sort of restriction on how many people we can have in a class and so on. Okay. And of course, your role as the Director of Teaching, you don't want to be too restrictive to individual lecturers, do you? Because if you just sort of say everybody has to do X, then it's a little bit like we're
Yeah, no, they all have their own, they bring their own expertise and creativity to the table, and I want to make sure that that's harnessed as much as possible, certainly.
Yeah, we do get some really interesting suggestions, don't we? And
yeah.
Sometimes, I think to most people, I tend to be on the more sort of Luddite end as far as the technology is concerned. I really need somebody else to show me like the easiest way to do it, or a really convenient way to do it. And then some other members of staff have got really sort of snappy, oh, we can do this thing, like setting quizzes, or sort of automating the process where we set quizzes online and so on. So
yeah, and I think the interaction at Lancaster has a good system where there's a sort of a central digital learning team who develops solutions that can be rolled out to the whole university, really. And they've been, in the last few months, this summer term, with this quick switch to online teaching, I think that's worked really well. They've come up with solutions really quickly, and even as the technology is changing, because as now we're using things like Microsoft Teams a lot more, and Teams is constantly updating as well, and so they'll quickly roll out like, here's the new thing that you can do, and that's been really effective, I think. So
yeah, the sort of break-off rooms, I think that's one of the things that we found is quite useful. So it's being able to sort of split up an existing class into sort of smaller discussion groups. That's one of the things that we've considered using quite sort of prominently, isn't it? So yeah, it's all happening in real time. Do you have any idea, just as a sort of final point on the head of Director of Undergraduate Teaching? So you've been doing that for 3 years.
yeah.
So you're very happy doing it. I think that it's something that you quite enjoy.
Yeah, I enjoy it. Yeah.
So, but is there like a term limit or?
Oh, I don't think so. I haven't been told of one,
Okay.
so yeah.
So you're gonna do it. You're gonna do it for okay
I know.
for the time being. So that's
Yeah,
good. Yeah,
certainly for next year anyway.
yeah. I think the stability at the moment is probably a good idea. So, okay. Now I'd like to ask a bit more about your research specialism. So
Sure.
you said certain phrases that I think algebraic groups and I can't remember what other
I think I
phrase.
said they're representations, but that won't necessarily mean anything to. I mean, I
Yeah,
think broadly this is sort of the thing that interests me is algebraic structures and their symmetries, maybe is another way of saying it. And one thing I could say a little bit about is what maybe some examples of things I mean by algebraic structures. Is that
right. Okay, so I mean, algebraic structures, I was it means different things in different contexts.
yeah, absolutely.
Let's we're not okay. So we're not talking about operads or anything like that. So
No, I can
so I mean, groups, just to relate it, I think many people will have heard of groups. And so groups are a kind of a sort of form of mathematical structure which tends to be related to a notion of symmetry of an object
yeah.
or symmetry of something else. And in the undergraduate curriculum here at Lancaster, that's sort of first tackled in any serious sense in the second year in our abstract algebra module. And then subsequently in the third year, there are a lot of optional modules that you can take, including one in representation theory, although there will be two versions of representation theory in due course. There'll be one which is to do with algebras and one which is to do with groups, further topics in group representation theory. And once you get to sort of understand those groups, you've kind of got sort of more specific types of group, right? So I guess that's what the algebraic group is, a specific type of group satisfying a particular kind of set of rules. Would you say that's
Yeah, I think that's one way of putting it. I think, yeah, that's right. Should I say? I could share my screen and say.
Yeah, sure. Yeah.
Words here. Let's see if I can. Here we go. Can you? Is that shared? Can you see this?
No.
Does it take a second? Try again. Sorry. Here we go. Let's try again. How about that? Can you see this now?
Yeah, that's better. Yeah.
Okay, right. So the thing I wanted to use as an example is kind of numbers in quotations, which have a multiplication and length that are compatible. So, for example, when I say compatible, I mean like this. So you have like x. You have numbers x and y. The length of x times y is equal to the length of x times the length of y. Okay. So here's an example. So I'll give you a moment. Hopefully you can think of first example, by which I mean real numbers, right? So these have a multiplication and the length obeys this thing. Real numbers, as people should think of, is one-dimensional. All right. So you see my table here. You can sort of see where I'm going. Now I'm going to put the number 2 in there. Okay, folks at home, what is two-dimensional and has a multiplication and length which are compatible? Hopefully, you thought of complex numbers.
Yeah.
All right. So then the interesting thing, you say, okay, that's one-dimensional. Two-dimensional is complex numbers, sort of you think of as a plane. And then you think, okay, 3 dimensions. Is there a 3-dimensional multiplication? So you take 2 vectors in 3 dimensions, multiply them together to get a third one in a way that's compatible with length. And the first thing that you might think of is cross products.
So cross product on vectors. So just to, not everyone will have seen this. Some undergraduates will have seen it, but this is a sort of rule for making a new vector out of a pair of vectors with 3 entries, right?
Exactly, yeah, in 3 dimensions this works. But this doesn't satisfy this rule of compatibility of the length, because, for example, if you know about cross products, the cross product of a vector with itself is always 0. And so that means that that equation is not satisfied. So this does not work. And the interesting thing is that there are none. You cannot have a multiplication in 3 dimensions which have these two. So that's an interesting fact. And then the discovery is that in 4 dimensions, there is one. There's quaternions is what it's called. So this is, I'm going to put the date in there as well, 1843 discovery. And then let's see, add some more rows to the table. So this is the fun thing about, what I like about this question is that it's simple enough that you wouldn't even think it would have a coherent answer. It's like, oh, all numbers that have multiplication to length that are compatible. It seems like it's too general, but you can make it precise enough and get actual information.
So just to be clear, when you say numbers, you're talking about a number system which has to satisfy certain rules. So
yeah, that's right. So I haven't given you exactly the rules, but this is how you'd probably think about it.
You're looking at systems of numbers, and everybody can see what the real numbers, well, at least if you've done A-level maths, you'll have met real numbers and possibly complex numbers.
And so quaternions, this is like a generalization in 4 dimensions. And then you think, okay, there's nothing in 3, nothing in 5, 6, and 7, it turns out. And actually, when you get to 8, big surprise, there is something, exclamation mark. And then 9 and above, again, none. So that's it, actually. So this is the complete list. And from such a simple question, you wouldn't think that there would only be 4 cases, but there is this case. And that's the attractive thing I find about these kind of structures in algebra, is that from relatively simple rules, you can say, actually, here are all of the things that satisfy those rules. So
just for the sort of maybe undergraduates who've done the second year, can you say what things you're looking for when you say numbers? What would be the mathematical?
Well, I mean, I guess it would be, I'd say these are real vector spaces. That's what I'd say. Right. So real vector spaces which have a multiplication and a length. So by length, if you're taking second year linear algebra, this would be a positive definite, or even an inner product is what one way.
Yeah. And they have to be just rings, or is there a
multiplication? Yeah. So it's like an I guess as an algebra structure. So it'd have to obey the length. So when you scale, the length will have to scale, and the multiplication would respect scaling. But
right. Okay, so it's and the difference between it's a ring which is also a real vector space and satisfies some extra properties. Now the complex numbers, that's obviously commutative.
Yeah, that's right. These quaternions are not, and noctonians are not.
And octonians are not even associative. So for people who've done 225 abstract algebra, they will hopefully be able to remember the definition of associativity of the multiplication. So the octonians fail on that one. So you're losing some of the structure as you go to these larger dimensional examples.
Yeah, and you might think, well, how could you possibly know that there are none in? This is when I first came across this. I remember thinking, how could you know that there's none in 3 dimensions, none in 5, none in 6? And the answer, it's a very algebraic proof, but the essence is that if you were to have, so these things are called composition algebras, and if you were to have a composition algebra, it's you can prove that you can essentially cut it in half. So if you have one, then you can like cut half of the dimensions and make that another composition algebra.
Right.
So that process means it already rules out anything that isn't a power of 2, basically. Because since you have to always be able to cut it in half down to 1 dimensions, then it has to therefore be a power of 2. And so that rules out everything except for powers of 2. But then you say, well, what about 16? Well, why can't you have a 16-dimensional one? And the answer is basically because because you can cut it in half in this way, you get down to the octonians. you'll be able to create two vectors which multiply together to give 0. And that will break the length requirement. So you have two things that are not length 0, multiply them together to get 0. You can always do that. So that's why it doesn't work for 16 or any above. So that's essentially the sketch of the proof of that. So there's a name of this. Maybe Hurwitz's theorem.
Yeah.
It's this classification. Yeah. So there you go. That's what I'd say. And the symmetry, the link to, say, my research, the symmetries of these things are, as algebras, is an interesting question. I mean, the real numbers don't have any symmetries if you put the right constraints on it in this sense. So you fix the unit and the length. There's no. The complex numbers do have a symmetry. If you fix the number 1 and the length, you can swap the I to minus I. So there's an order 2 symmetry. Quaternions have actually a symmetry group of SO3, so rotations in three-dimensional space, which is an interesting one. There's deep links between the quaternions and rotations. And octonions, the symmetry group, as I'm sure you know, Paul, is G2, the exceptional group G2, which is a 14-dimensional group and a very interesting one. And that's the link. So that these higher dimensional groups that I've been just describing, symmetry groups, in the same way that you can classify these, you can also classify in actually what I'd say is a surprising way, such groups. There's sort of a relatively simple definition you could write down and say, actually, these are all of them, and write down a classification. And in that classification, there are these exceptional ones like this G2, the automorphisms of the octonions, and that's kind of one of the things I'm interested in for research. So that's what I'd say for that. Yeah,
I wrote down on my list of questions to ask you about research is to say, what is E8? E8 may be something people have heard of. Now it's essentially the same question as what is G2, right? I mean, the people studying research algebra, they like to classify things, whether you classify all of the finite simple groups or classify the composition algebras over the real numbers, or classify the finite reflection groups, for example. That's something that one of my dissertation students did this year. Classifying things can be sort of very, very useful once you have a list of all things that satisfy certain properties. Then that can be useful if you then want to know, well, suppose I have a finite group, can it satisfy something else? And you just look at the list and see whether any of these groups on your list satisfies it. So it's something that is sort of a little bit like, I guess, algebraists are the kind of people who put their CDs in alphabetical order or in some category order, maybe according to genre or whatever. So it's definitely a part of the thinking, which I don't see quite so much in some other fields of mathematics. Now, the G2 that you've mentioned there, so that's an example of, I suppose, a simple Lie group.
Mm-hmm. Yeah. Right. Yeah, if it's over the real numbers, Lie group, yeah.
Yeah, so I mean, this does sort of relate somewhat to the undergraduate program in that there is a fourth year module on Lie groups and Lie algebra.
That's right, and there's a dissertation. I sometimes wrote a dissertation, fourth year dissertation, on this question actually of showing that the octonions have symmetry group of G2. That's
yeah.
It's a complicated one. I mean, this isn't a simple thing, obviously, but it's accessible.
It's an 8-dimensional thing, and it has a 4-dimensional. 14-dimensional.
Yeah.
So I guess you can sort of see that kind of concept a little bit more clearly with the quaternions, where you say this symmetry group is SO3. Now that's also the symmetry group of a sphere, right?
Exactly. Yeah. So you have a sphere, a fixed point in the middle, all the rotations.
So if you think about the surface of the sphere like the surface of the Earth, you've got essentially two directions, which is north-south or east-west. So it's a 2-dimensional object. The surface of the sphere looks locally to us like a flat plane, which is a 2-dimensional object. But the symmetry group is this SO3, which has dimension 3. So
I'd say, and so there's an interesting way of knowing that aviators know this, because they have names for the different. So there's let's see if I can get it. So there's the pitch. No, which is pitch? Pitch is like this.
Yeah.
Roll is like that.
Yeah.
and yaw is like this. So those are the
Uh-huh.
three, there's sort of three parameters that describe these rotations in space. So
Uh-huh.
this is because in a
I'd heard
plane,
those words, yeah.
yeah.
I'd heard those words, but I didn't know what they were. So yeah. Interesting. Okay, so we maybe won't ask you what E8 is, but the E8 is another one of these sort of either a simple Lie group or a simple algebraic group or something which fits into this classification, and it's a big one.
It's a big
So
one, but it's one of the most beautiful ones as well. It's, I think beauty and symmetry are closely related, and it's extremely symmetrical. And I think that's an argument one could realistically make.
the aesthetics of mathematics are something that's
Absolutely.
hard to get across to most members of the public. Yeah.
It's an important thing.
What is an elegant proof, for example? That's something which is quite hard to explain. So, okay, well, thanks for that. That little aside, which is on your a little bit on your research specialism, but also your one of your favourite theorems. So I'm going to come back to teaching now.
Sure.
As I said earlier, you teach this Linear Algebra 2, so the sort of more advanced linear algebra course in the second year. In the first year, it is it will be, the linear algebra in the first year will be sort of somewhat familiar to some people who've done further mathematics at school. And so it's building on the kind of linear algebra that everybody's learned up to that level, and going to slightly more advanced and more sort of in-depth discussion of the topic. Do you want to say any more about that, or?
Yeah, so I say, yeah, exactly as you say, it builds on the first year one, which is the one that took place remotely this year. I would describe where it fits in the curriculum is, so our department is broadly speaking split between a statistics section and a pure math section. And if you were to identify one module which is a bridge between those two, I would say it's the linear algebra module, the 220, because it does feed in to both quite strongly. In the curriculum with the prerequisites, it looks more like a pure maths module, but the concepts used in it are also used in the stats side quite heavily. So I quite like that position. I mean, the concepts, there's like inner products, and there's a spectral decomposition, which is covered, which is used a lot in there's like physics and stats applications for this. And then there's finishes with this Jordan normal form, which is a bit more abstract, but also useful in several of the pure maths third year modules. So yeah, that's what I'd say. It's a fun one. It's a very big one in terms of number of students, because pretty much all students take it, the single majors, including the combined students, because we have quite a lot of combined degrees, and almost all of them take 220 as well. So it's a big one, yeah. Feeds into quite a lot.
Yeah, I mean, that Jordan normal form is sort of interesting. It's still sort of related to a kind of ongoing research into, for example, nilpotent elements of Lie algebras and so on.
Well, that's your area, isn't it? Yeah.
That's my area. So it's very much, even though the actual sort of discussion in the course is pretty, like most undergraduate sort of pure maths curriculums, it's mostly it's not recent research that you're talking about. It's only the odd sort of module that might talk about something which is kind of more recent.
And one of the goals of this module as well is to really ramp up the students' familiarity with kind of basic concepts in pure math, like abstraction and proving things from these types of axioms and stuff like this, and the way things are proved in pure mathematics, which is still not easy to learn. It doesn't come naturally to humans, right? So this is part of the goals of this module.
Yeah, so it's at the base of the, as you say, the kind of the pure maths, but also the statistics kind of offering. Whereas the kind of course that I teach in the second year, this complex analysis, probably doesn't particularly relate to anything on the statistics side in the third year. So yeah, it's a kind of it's a key sort of keystone module, isn't it? Practicalities, obviously, this is going to be running in Michaelmas, so you have, what is it, 10th of June now. You've got less than 4 months to kind of firm up those plans as to how the teaching is going to take place. Have you got anything that you can be certain
Yeah, I mean,
about?
the basic structure is going to be very similar in the sense that it'll be a 10-week module. We'll have a team of PhD students helping assess work and give feedback on work. Though likely won't be lectures of 200 or so students in the room, but there will be lecture delivery, going through examples and theory from the notes. That's essentially the core structure will still be like that. One aspect that I introduced a few years ago is these in the workshops is the tests. So there's just sort of a short test at the end of each workshop, which culminates. I've been getting them to work in small groups of about 5 or so. Given a list of problems, there's like 5 or 8 problems during this 2-hour workshop. Work in your groups together, collaboratively get an answer, and then have an individual test. And I think this has been working really well. Unfortunately, this year, it might not be possible to work it in exactly that way, but I'd still like to have some kind of see what I can do to replicate this type of environment in a more online setting, if necessary.
Yeah, so this is one of the uncertainties, isn't it? About you want to go for the optimum, and in some ways, moving to pre-recorded lectures has advantages anyway. So just as I said to Johnny 2 weeks ago, that we probably would have liked to do some of this thing, but by choice and actually design the course as a whole rather than in real time having to adapt these decisions so quickly. So it does open up some opportunities, but also, I mean,
that's right. We don't want to reinvent the wheel. It's just it's not feasible. So but I'm confident we'll be able to adapt anyway to whatever situation. So
do you use notes with gaps?
Not in 220, no. It's all the notes are there right from the start. You get to see all the notes, all the exercises right from the very start. So
you talk around, you give them a copy of the notes, which normally would include the possibility to have a printed copy, but also an electronic copy, a PDF of the notes. And some lecturers in our department sort of leave certain gaps that they will discuss and write things on, maybe an example in the lecture, but you don't do that. You just include a complete copy of the notes and then talk around things as you go on. Is that?
Yeah, exactly. And I usually have a piece of paper. In normal times, I would have a visualizer. I'll probably have some sort of setup similar to that if it has to be remote delivery, where I just by hand work out examples and talk about how to do the processes and talk about the theory in the module that way. So that'll basically be the same. I think it's worked well in the past, so no need to tear it up this year.
And if you thought, if you did have to pre-record,
I think pre-recording works well, actually. In many ways, an hour is quite a long time to hold somebody's attention. And I think splitting it up into smaller bits can be effective. I think one thing that I really liked about lectures is the interactive element, and in a large class it is possible to get like interaction and sort of even get students talking with each other at appropriate times. In an online format, the limited experience I've had, that's more difficult to do, but I don't think it's impossible. So we'll be looking to run some live sessions where we have some kind of interaction like this. But this is still, there's a lot of unknowns, but that'll be my hope.
I think it's sort of quite exciting in a way, isn't it? It's kind of like, I could do this, and you need to sort of rein it in a bit at some point and say, right, I need to think about something I can sustain for 10 weeks, and that sort of, you can have lots of ideas, but you sort of need to think about, well, the ideas, so you also need to be looking at the learning objectives and all of the things that we write, which is basically what do we want people to learn from the course, what do we want them to do, what kind of mathematical knowledge, and how do we want them to show us that they've got that mathematical knowledge. So you've always got to have that in mind when you're thinking about designing all of these sort of different sessions, and you don't really want to waste time on something which looks good but maybe distracts from the main goal, which is to try
absolutely
thing. So it's but it's quite fun to think about. We'll know more in due course, but it's quite fun to think about. And of course, at the end of the year, I think we'll probably have to we'll have the annual courses review day and probably think about, right, really, are we making some decisions now about how we're going to teach? So
yeah, definitely.
I guess even we as staff will find out in due course.
Yeah, that's right. And I think the interesting thing about it is changes for this year, obviously, they'll be quite substantial. But I think even after this whole situation is over, some are likely to stay, right? Like, I think this is going to be a shift to how some of us will realize, actually, maybe it's better to do it in certain ways that we hadn't thought of before. So I'm looking forward to that kind of change in the future as well, seeing what worked well. Because I don't think it's going to be back, in 5 years' time. I don't think we'll be just teaching the same way we did last year, for example.
Well, it's accelerated something, hasn't it? Because I remember when I started teaching. When I was a student, nobody got printed copies of notes, and you just had to go to the lecture and write down what the lecturer was writing on the board and try and do so and get as faithful a copy as possible of what the lecturer was writing, and that's it. You had your copy of the notes, and that was what you needed to know. So when I started teaching and we had these printed copies of the notes, I think it's something I sort of wrestled with over time to think about, well, what is the purpose of the lecture if they've already got a copy of the notes? They could just be sat reading it. Now, some people prefer to have a verbal explanation, but verbal explanations don't serve the same purpose as written ones. There's the different sort of type of understanding. So you're sort of transforming the kind of the purpose of the lecture into something which is more suitable for the kind of technology that we've got.
Yeah,
I think this will accelerate that process in a way in terms of thinking creatively about what is the best way to learn the things that we want. Some bits of knowledge are better at bite size. Others maybe really want to sit down and kind of actually struggle with for some time. And a lecture obviously wouldn't be the ideal, but maybe the talk classes could be one way of sort of creating an environment where people can spend some time trying to get more transformational sort of knowledge in a way, and a change in the way that your brain processes things and the way that you think about the subject. So
that's right. I mean, I think ultimately a learning experience is not just acquiring knowledge. I mean, to acquire knowledge, humans do it. It's a very social activity. I mean, you only really absorb things when you see that it matters to other people, and that's why it's so important to have this interaction. So that's definitely, you talk about purpose of lectures. It's not just transmitting knowledge. There's so much more than that. So we want to make sure we capture that, whatever happens going forward.
Okay, well, thank you very much for that, Mark. And every week I kind of finish off by saying, well, I'll see the people watching it maybe in a week, and I'll probably see you at a meeting maybe later this afternoon, online at least.
Yep.
So for people watching, next week's episode, or the next episode, which will appear in the next few days, is going to be a special postgraduate episode with Emma Easter from the postgraduate program in the department. So that's going to be a nice sort of alternative, because we also want to see how the postgraduate side, the master's courses and so on, how they're thinking about how they're going to teach their courses over the next year or so. So tune in for that, and thanks to Mark. Thank you, everybody.
It's all right. See you later.